In the previous episodes, we studied mechanical waves. Now, let's study electromagnetic waves. Observing a rainbow in the sky after a rainy day is a delightful experience. When sending a voice note, watching TV, listening to the radio, or heating up dinner with a microwave oven, electromagnetic waves are being utilized. Maybe you have had an X-ray to see if you had broken a bone. X-ray is an electromagnetic wave. Electromagnetic waves are present everywhere around us, but most of them are invisible to the human eye.
In previous episodes, we have seen that mechanical waves are produced by vibrating objects. Now, electromagnetic waves are produced by accelerating charges. Unlike mechanical waves, electromagnetic waves can travel through vacuum. And of course, they can travel through material mediums like solid, liquid, or gas. But what do we mean by an electromagnetic wave? An electromagnetic wave consists of an electric field E and a magnetic field B oscillating with the same frequency in two perpendicular planes. Observe. The electromagnetic wave is transverse since E and B are both perpendicular to the direction of propagation of the wave.
One method to generate electromagnetic waves involves connecting one end of a conducting wire to one pole of a dry cell. Subsequently, by briefly hitting the wire's other end to the other pole of the dry cell, the charges in the dry cell gain acceleration and produce an electromagnetic wave. This wave can be detected as noise by the radio. This procedure can be repeated multiple times.
All electromagnetic waves propagate in vacuum with the same speed, whose value is 3 times 10 to the power 8 meters per second. But how can we determine the speed of an electromagnetic wave in another medium? Look at this figure. A laser light in air strikes obliquely the surface of water. The frequency of light does not change as it crosses from air into water, since it depends only on the source of this wave, whereas the speed changes, since it depends on the properties of the medium. Now, if the refractive index of water is n, then the speed of light in this medium is c over n. Now, pay attention to the units. N is unitless, then the unit of the speed must be the same as that of c. So, if c is expressed in meters per second, then v is also expressed in meters per second.
Focus, please. This is important.
Like the mechanical waves, electromagnetic waves obey the wave equation V equals lambda times F, where V is the speed of the electromagnetic wave in the medium of propagation, F is the frequency of this wave, and lambda is the wavelength. So, lambda is given by V over F. In vacuum or in air, the speed of the electromagnetic waves is c. Therefore, the wavelength of the electromagnetic wave in vacuum equals c over f. Visible light is the only electromagnetic wave that can be seen by a human eye. In some references, the wavelengths of visible light in vacuum range between 400 and 800 nanometer.
The electromagnetic spectrum consists of all electromagnetic waves. The various kinds of electromagnetic waves are listed in this figure. Here we have gamma rays, X-rays, ultraviolet, visible electromagnetic waves or visible light, infrared, microwaves, radio waves, etc. As you see in the figure, there is no clear boundary between each wave type as they blend into one another. Now look at the values of the wavelengths of the various kinds. As you see, the wavelength increases as we move from gamma rays to X-rays to ultraviolet, etc. Now look at the values of the frequency. Since the wavelength and the frequency are inversely proportional, the frequency increases as we move from radio waves to microwaves to infrared, etc. Now look at the bottom of the figure. The visible light spectrum is expanded to show details of the colors. The visible part of the electromagnetic spectrum consists of the colors that we see in a rainbow.
White light is a polychromatic light composed of all the visible wavelengths or colors. When white light falls on a triangular prism, it undergoes refraction. Therefore, light is dispersed or separated into its constituent wavelengths. The rainbow is the most famous example of dispersion and is formed when the sun shines directly on rain droplets.